So this is the question. A compound has a molar mass of 99 grams per mole and contains 24.8% carbon, 3.9% hydrogen, and 71.3% chlorine. Determine the empirical formula, then 2, molecular formula of the compound. Now, how do you go about this question? The first thing we'll do is to write out the elements that are involved in the compound. So the compound involves carbon, hydrogen, and chlorine. Then the next step now is to write the percentage by mass of each of the elements underneath. So the percentage of carbon is what? 24.8%. That is right. What is the percentage of hydrogen? 3.9. That is right. And what is the percentage of chlorine? 71.3%. Then the second step now is to do what? Divide by the molar mass of it. So hydrogen, carbon will be what? 12. So divide by 12. The relative atomic mass of carbon, hydrogen is 1, so divide by 1. And what of that of chlorine? So we divide by 35.5. Now what will be 24.8 divided by 12? Will give us 2.07. 3.9 divided by 1 will give us 3.9. And 71.3 divided by 35.5 will give us 2.01. Which one is the smaller or the smallest number here? So divide each one of them. The essence of dividing by the smallest number is to find the whole number, because what we need is the whole number. So divide by 2.01, divide by 2.01, divide by 2.01. And what is 2.07 divided by 2.01? That is 1. The ratio. What is 3.9 divided by 2.01? 1.9. That should be approximately 2. Then divide by that will give us what? 1. Now it means the ratio of the compound given to us will be 1:2:1. And that means we have 1 atom of carbon combining with how many atoms of hydrogen? 2. And combining with how many atoms of chlorine? So this one here is this. You can see therefore the empirical formula is equal to CH2Cl. That is the empirical formula of the compound. So that means we are done with the first part. The second part says we should find what? Molecular formula. So in order to determine the molecular formula, we have a CH2. So since we have been given the molar mass of the compound to be 99 grams per mole, what it shows is that when we calculate the total number of the mass of the element present in that compound, everything should give us 99. So let us assume that the total mass in X will give us what? 99. One is 12 plus 2 atoms of hydrogen will give us what? 2. Then what is the mass of the chlorine here now? So 35.5. Everything together multiplied by X will give us 99. Now what is 12 plus 2 plus 35.5? 49.5. 0.5x is equal to 99. From here we can find the value of x. Then we can say x is equal to 99 over 45.5. And this will give us what? 2. Then to get the empirical formula, that means we come to this empirical formula here and multiply by what? 2. So we can say the empirical formula is 2. Therefore, the molecular formula is equal to CHCl2 into 2. Then each of the atoms in the bracket should be multiplied by 2. So that would be CH2Cl. That is right. So that would be C2H4Cl2. So the empirical formula for the compound is CH2Cl, while the molecular formula is C2H4. Who can tell us the name of that compound? Dichloromethane. No. How many can, okay, maybe if I draw the structure of prevention, you will get this right. (28.1%), chlorine 35.7%, water of crystallization 36.2%. Then calculate the formula of the material. We have chlorine and we have water of crystallization. So these are what the materials contain. Then what is percentage by mass of the iron in the material? We have 28.1. Percentage by mass of chlorine is 35.7, and that of water of crystallization is we have 36.2. Now each of the materials, what the material contains should be derived by each of their atomic mass. So what is the atomic mass of iron? 56. Atomic mass of chlorine is we have 35.5. And what is the relative atomic mass of water? I hope you all know how we arrive at 18. Yes. So you had the mass of hydrogen 2 atoms, which is 2 plus 16. So that will give us 18. Now what is 28.1 divided by 56? 0.5. What is 30? That is what? 1. Then 36.2 divided by 18? 2. Now, when you are finding the empirical formula, or anything that has to do with ratio, you don't just approximate. Okay, let us find divide by the smaller number here is what? 0.5. So let us divide by 0.5. Divide by 0.5. Divide by 0.5. What you have here is what? What you have here is what? And what you have here is what? 4. Now, the empirical formula now, or the formula of the material now, therefore, the formula of the material will be equal to what? FeCl2 dot what? 4H2O. Who can tell me the name of this material? Please clap for him. Iron 2 chloride tetrahydrate. That is the number of molecule of water crystallization there is 4, and that is what? Tetra. Now I'll do one more question for you before I give you the one you are going to do in your own. Na2SO4.XH2O was heated to remove the water of crystallization. So the remaining anhydrous salt had a mass of 2.12 grams. Calculate the value of X in the hydrated salt. One of the ways to solve this question is to use the method of empirical formula. That is, the hydrated salt will contain 2 parts, anhydrous part and water of crystallization. Now, the hydrated salt that we are given is Na2SO4.SH2. So this is the anhydrous part of the salt, and this is the water of crystallization that is attached to it. So we can break it into 2 and find the ratio of anhydrous salt to water of crystallization. So we have Na2SO4 as one part, then we have H2O as the second part. The mass of the hydrated salt is the combination of the masses of the anhydrous part and water of crystallization, and that gave us 4.3 grams. when the mass is heated, you expect the water of crystallization to be lost. What is going to remain will be the mass of anhydrous salt, and this is what you are given. How do we get the mass of the water of crystallization? So here we can say mass of water of crystallization will be equal to what? That is 4.3 minus 2.12, and that gives us what? 4.3 minus 2.12, 2.18 grams. We have broken the hydrated salt into anhydrous and water of crystallization. So let us write the mass of anhydrous salt. What will be the mass of anhydrous salt? 2.12. And what is the mass of water of crystallization? 2.18. This is 2.18. What do we do now? Divide the molar mass of anhydrous salt. What will be the molar mass of anhydrous salt? Now quickly do that. Do the calculation. Molar mass of Na2 to, let us say, relative atomic mass of Na2SO4 will give us what? That is 46 plus 32 plus 64. And that gives us what? 142. Also, we need to know the relative atomic mass of water. So, the relative atomic mass of H2O will give us 2 plus 16, and that will give us 18. That means now we come to this one. We divide the anhydrous salt, the mass of anhydrous salt, by the molar mass of the anhydrous salt, and that is what? 142. Then divide the mass of water of crystallization by the relative atomic mass of water, and that is what? What is the relative atomic mass? 18. Now divide 2.12 divided by 142. 0.015. Now 2.18 divided by 18. 0.121. Which one is the smaller number? So divide by 0.015. Divide by 0.015. I think this will give us 1. The ratio, this will give us what? 8. It means if we want to find the formula of the hydrated salt, the ratio of the anhydrous salt to water of crystallization is what? 1 to 8. That means when we have 1 mole of anhydrous salt, which is Na2SO4, will combine with what? 8 molecules of water of crystallization. So therefore the value of X, you know we have to find the value of X. Therefore, what will be the value of X? The value of X is equal to 8. Sodium tetraoxosulfate octa-ion. Octa means what? Yes. Let's clap for him. Now, give the exercises you are going to try your own. I'll give you 3 or 4 exercises, and let us see how we go about it. A sample of a substance containing carbon and hydrogen bonds in excess oxygen to yield 4.4 gram of carbon dioxide and 2.7 gram of water. What is the empirical formula of the substance? Then number 2, 5 gram of a compound Y was heated to a constant mass. 1.8 gram of water vapor was given off. They determined the number of molecules of water of crystallization in 1 molecule of Y, given that the molar mass of its anhydrous salt is 60 gram per mole. have any question on this one? This is your photo. Substance containing carbon and hydrogen. The compound you want to find the principal formula should contain what? Carbon and hydrogen. And your whole answer you are having CO2, H2O. Automatically you have missed it then. Automatically what you have is that when hydrocarbon is burnt in oxygen, we have what? CO2 and H2O. The values you are given, this CO2 here, 4.4 gram of CO2 and 2.7 gram of H2O, was as a result of conversion of the hydrocarbon. What you need to determine now is that we need to know the mass of carbon and the mass of hydrogen that is present in the hydrocarbon. How do we do that? For us to have CO2, this CO2 must have derived from combustion of carbon, and the H2O must have gotten from where? Combustion of hydrogen. So we need to get the mass of carbon from carbon dioxide and the mass of hydrogen from water. Are we together? How do we do that? Calculate the molar mass of carbon dioxide, then find the relative mass of carbon over the molar mass of CO2 times the 4.4 gram given to determine the mass of carbon. Am I communicating? You are not getting it? Yes. When the hydrocarbon that contains carbon and hydrogen, hydrocarbon contains carbon and hydrogen, it was when it was burnt in oxygen that we have what? Carbon dioxide and steam. Do you understand that? Yes. What are the products of combustion of hydrocarbon? Carbon dioxide and what? Steam. It means if you are getting the carbon dioxide here, this carbon dioxide was gotten from combustion of carbon. So now, by the time I solve it, you understand it. I want to determine the mass of carbon in the carbon dioxide. What I will do is to find the relative atomic mass of CO2 equals to 12 plus 16 times what? 2. And that's equal to 12 plus 32, which is 44. That means the mass of the relative atomic mass of carbon dioxide is 44. Now I want to determine the mass of carbon that will be present in 4.4 gram of carbon dioxide. What would I do? What is the mass of carbon? is the relative atomic mass of carbon form type. That is 12. So mass of carbon is equal to 12 over 44 times what? 4.4. And that will give us what? It means the mass of carbon present in that substance is what? 1.2. So the relative atomic mass of H2O will be equal to what? 1 times 2 plus 16. And this gives us what? 18. Now, how do we determine the mass of hydrogen in the water vapor? Therefore, mass of hydrogen will be equal to, that is 2 over 18 times the mass of water vapor, which is 2.7. Now what is 2 over 18 times 2.7? 0.3. Now we know the mass of carbon, the mass of hydrogen. We can now find the, so we have carbon, hydrogen. These are the elements that are present there. 0.3. You can now divide them by the atomic mass. But the atomic mass of carbon, what is the atomic mass of carbon? That is 12. Divided by atomic mass of hydrogen, which is 1. What is 1.2 divided by 12? 0.1. So 0.3 divided by the smaller number. So divide by 0.1 divided by 0.1. This was 1. Therefore, empirical formula is equal to 1 carbon and 3 hydrogen. So the molecular mass of that compound is equal to C. 5 grams of a compound Y was heated to a constant mass. 1.8 grams of water vapor was given up. Then determine the number of molecules of water of crystallization in 1 molecule of Y. Given that molar mass of the anhydrous salt is 60 grams per mole. This is similar to the one I worked for you. It means compound Y will be hydrated salt. And when the compound is heated, you are going to have 2 parts. You have anhydrous salt and the water that is lost. Now let us write, because this name of the salt is not mentioned. All we are interested in is we want to find the number of molecules of water of crystallization. So let's say the anhydrous salt, anhydrous salt, then we have what? Water of crystallization. What will be the mass of anhydrous salt from what is given here? You know what we are given? We are given the mass of hydrated salt, which is 5, and we are given the mass of water of crystallization, which is 1.8. So to get the mass of anhydrous salt, that will be 5 minus 1.8. And that will give us what? 3.2. And of course, the mass of water is 1.8. Okay? Okay. And 1.8 divided by 18 will give us 0.1. Then which one is the smaller number? So divide by 0.053 divided by 0.053. It will give us 1:2. That means the number of water or molecule water crystallization will be what? So you can say molecule of water of crystallization is equal to 2. How many of you got this one right? I believe it will. The basic principle behind the first one was what did not get right, and that is why you use it. Now let us move forward. Let's look at another question. You are going to do it yourself, okay? And the question is this: contains 27.3% carbon and 72.7% oxygen. When 350 centimeter cube of the compound at STP, its mass is 0.69 gram. What is the molecular formula of the compound? Then quickly solve it and let's see what you got. Why are you making noise? This is the one I asked you to do. I don't understand. So let us solve the prevention with the answer to before I leave the class. Now let's go through the question. A certain gaseous compound contains 27.3% carbon and 72.7% oxygen. Its mass is 0.69 gram. From there, let's first of all determine the empirical formula of the compound. Other information given from this place will be used to determine the molecular formula of the compound. So, what are the elements present in the compound? Carbon and oxygen. What is the percentage by mass of carbon? 27.72.7. Now we need to define each of these elements by its atomic mass. What is the atomic mass of carbon? We have 12. What is the atomic number of oxygen? 16. So what is 27.3 divided by 12? 2.3. 3 what? 2.27. Please avoid approximation at the initial stage. It will not give you the right answer. So what is 72.7 divided by 16? 4.544. Now divide by the smaller number. This is divided by 2.275 divided by 2.275. And what do you have? 4:2. Then the empirical formula here, empirical formula will equal to CO2. In order to determine the molecular formula, we need to know the relative atomic mass of the compound. And that is why you are given the further question here. So how do we determine the molecular mass of this compound? We are told that 3 centimeter cube of the compound at STP contain 0.69 gram. How do we convert this information to the molar mass or the relative atomic mass? We can use this formula to do that. Mass of the gas produced over the relative atomic mass is equal to volume at STP over gas molar volume. Mass molar volume. So this will help us to calculate the relative atomic mass of the compound. Mass of the compound over the relative atomic mass is equal to the volume at STP over the gas molar volume. The mass of the gas is given. What is the mass? We have 0.69. We are looking for the relative atomic mass. What is the volume of the gas at STP? Most of you don't understand the volume at STP and gas molar volume. Look at the question saying when 350 centimeter cube of the compound at STP. So this volume here given is at what? At STP. And that is what? 350. So the volume at STP given is 350. Then what is gas molar volume? Gas molar volume is the volume of the gas. That is 1 mole of the gas at STP is equal to what? 22.4. But you cannot use 22.4 ppm because the unit given from the question is a centimeter cube. So you have to take that gas molar volume to centimeter cube. And it will be what? 22,400 centimeters. So it will be wrong for you to have centimeter cube or you now put dm cube down. The two units must be same. Therefore, the relative atomic mass now is equal to 0.69 times 22,400 divided by 350. And this will give us what? 44. That is approximately 44. We can now determine the molecular formula of the compound. So here we have CO2 into S is equal to what? 44. Atomic mass of carbon is 12 plus what is mass of 2 atoms of oxygen? 32. Everything into S will give us 44. So that means 44x is equal to 44. X is equal to 44 divided by 44. And that gives us 4. Therefore, molecular formula now. Molecular formula will be equal to CO2 into what? 1. And that is CO2. That means most time our empirical formula can be equal to our molecular formula. It means it's not in every case that the empirical formula is different from the molecular formula. But I will not allow you to stand back again. So that means you will take yourself to the back. I want you to mix among yourself so that you will help yourself. You know, teaching today nowadays does not involve the teachers alone. Once we have 2 or 3 of you that are getting in, those ones to teach those ones that don't understand. So in that case, you are helping yourself. You put it in S, then equal it to 78 that you are given. The answer to this is 6. That wasting time. Now, the next question. We are still working on that? Yes, sir. So what is the empirical formula? CH2. So that is what I CH2. And what is the molecular formula? C4H8. What is the name of this compound? Butene. Before we call it, write the structure, the possible isomers of this compound, and corresponding name. Write the possible isomers of this compound and corresponding name. I hope you understand the question. Yes, sir. You have causing the molecular formula to be C4H8, which is protein. Then write the possible isomers of protein. Then write the name of each isomer. So, any question before we call it today? If there is no question, do enjoy the rest of the day. So, good evening, class.